Hey everyone, welcome Focus Learners, and a huge shout out to my Class 9 students joining us for this explainer. Today, we're unpacking something absolutely crucial, the intricate life support system of our planet. We're going to specifically dive into India's highly unique climate, look at how this massive atmospheric engine works, what happens when it gets thrown completely off balance, and, most importantly, what role you play in the whole story.
But before we get into the nuts and bolts of it all, I want you to just imagine something for a second. What would actually happen to life on Earth if the invisible shield protecting us suddenly broke down? Seriously, think about it. The Earth is wrapped in this perfect blanket of air that gives us the exact right amount of oxygen, perfectly regulates our temperature, and blocks out harmful space radiation. If that precise balance is disturbed, well, literally everything changes. And that's exactly what we're exploring today.
Okay, here is our roadmap for today. We're going to quickly cover the atmosphere's invisible blanket, weather, climate and seasons, the Indian monsoon, climate change, the shift, floods, impact and management, and finally, shrinking your carbon footprint. Let's get right into it.
Section 1. The atmosphere's invisible blanket.
So the atmosphere isn't just this one big, uniform cloud of gas. It's actually a highly structured system divided into 5 distinct layers based on temperature. Down at the very bottom, from the surface up to about 12 kilometers high, is the troposphere. This is our home. It holds the air we breathe, and it's where pretty much all weather happens. Clouds, rain, storms, the whole shebang. Just above that, extending up to about 50 kilometers, is the stratosphere. Because it's super stable and free from crazy weather, this is exactly where commercial jet planes love to fly. It also holds the absolutely vital ozone layer, which acts like global sunscreen by absorbing harmful UV rays. Beyond that, we've got the mesosphere, then the thermosphere, which is actually where the International Space Station hangs out, and finally, the exosphere, which just kind of gradually fades right into the vacuum of space.
Now, what is all that air actually made of? Well, nitrogen makes up a massive 78% of our atmosphere, and that's vital for plant life. Oxygen, which is obviously essential for us and all animals to breathe, makes up 21%. But here's the real kicker. It's that tiny 1% slice left over. That 1% holds argon, carbon dioxide, and a few other trace gases. Even though carbon dioxide is only about 0.04% of the atmosphere, it is a total heavy hitter. It's a greenhouse gas, which means it traps heat. Without it, Earth would literally be freezing. But as we're going to see a bit later, too much of a good thing creates a major problem.
Section 2. Weather, climate, and seasons.
Let's look at how this giant atmospheric engine affects our everyday lives. Now, this is a foundational concept for my Class 9 geography students out there. People mix these two terms up all the time, but they're very different. Weather is your short-term, day-to-day reality. It's the daily flip-flops in temperature, humidity, wind, and rain. You know, like, will you need an umbrella tomorrow? That is weather. Climate, on the other hand, is the big picture. It describes the average weather pattern of a specific place over a really long period, usually decades. The easiest way to remember it? Weather is your daily mood, but climate is your overall personality.
Because of its incredible, unique geography, India experiences very distinct changes in temperature, pressure, and wind patterns throughout the year. This breaks down into 4 broad main seasons. We've got the blazing summer season from March to May, the chilly winter season roughly from mid-November to February, the famous rainy season, also known as the advancing monsoon, and finally the transition period, which is the retreating monsoon.
Section 3. The Indian monsoon explained.
The monsoon is, without a doubt, the lifeline of the nation. It drives our agriculture, our economy, and pretty much the entire country's water supply. The word monsoon actually comes from the Arabic word mosam, meaning season, and it essentially refers to a massive seasonal reversal of winds. But how does it actually work? Well, it's just basic physics. Step 1. During the super intense summer, the huge landmass of northern India heats up incredibly fast. Hot air rises, right? So this creates a massive area of low atmospheric pressure. Step 2. Over the cooler Indian Ocean down to the south, there's high pressure. Since wind always wants to move from high pressure to low pressure, these ridiculously strong, moisture-heavy winds are literally sucked toward the Indian peninsula like a vacuum. Step 3. As these winds sweep across the land from the southwest, they drop all that accumulated oceanic moisture, bringing widespread, heavy rainfall from June all the way to September.
By early June, these advancing southwesterly winds slam into the southern tip of the peninsula. From there, they sweep right across the country, covering almost all of India in just about a month, cruising at an average velocity of 30 kilometers per hour. It's an incredible natural phenomenon.
However, just because the monsoon sweeps over the country doesn't mean everyone gets the same amount of rain. Not even close. The distribution is wild and highly uneven. Take the western coast and the northeastern states, they just get absolutely hammered with over 400 centimeters of rainfall annually. In fact, Moghzanram in the Kazi Hills gets the highest average rainfall in the entire world. But then look out west to Rajasthan and parts of Gujarat, they're bone dry, receiving less than 60 centimeters. This intense variability means the success or failure of these winds literally dictates whether farmers get a good crop or if the country is going to face devastating food and water shortages.
Section 4. Climate Change. The Shift.
Unfortunately, human activities are currently introducing a major glitch into this perfectly balanced natural engine. Remember that tiny 1% of the atmosphere containing carbon dioxide we talked about? Well, by burning massive amounts of fossil fuels, clear-cutting forests, and polluting, we are pumping way too much CO2 into the air. And because it's a greenhouse gas, it's trapping extra heat, completely changing long-term weather patterns across the globe. The effects are real, and frankly, they're terrifying. We're seeing highly irregular rainfall that leads to severe droughts. We're watching polar ice and glaciers melt at alarming rates, which is pushing sea levels higher. We're getting hit with extreme weather, deadly heat waves, and massive cyclones way more frequently. And as temperatures shift, plants and animals are losing their natural habitats, pushing a lot of species right to the brink of extinction.
And this isn't just some abstract concept for a science test. This impacts human survival right now. When regions that have relied on steady, predictable monsoon rains for centuries suddenly face erratic rainfall, the soil literally cracks, crops die off. This ruins local livelihoods, completely tanks food production, and puts drinking water supplies for millions of people in serious jeopardy.
Section 5. Floods, Impact, and Management.
Now, the tragic irony of climate change is that it doesn't just mean less water, it also means way too much water, usually in the exact wrong places at the exact wrong times. In India, there are specific regions that are highly vulnerable to massive flooding, heavily concentrated right along major river basins like the Ganga up north and the Brahmaputra in the northeast. Get this, every single year, about 40 million hectares of land in India are impacted by floods, mostly during that intense monsoon season. When continuous, heavy rainfall hits, these massive rivers overflow their banks, destroying crops, wiping out homes, and tragically, costing lives.
Floods are absolutely devastating. But here's the crucial takeaway. Human planning can dramatically reduce the disaster. We obviously can't stop the rain from falling, but we can absolutely manage the water. Effective flood management requires us to attack the problem from multiple angles. We need super strict early warning systems so communities actually have time to get out. In our cities, poor drainage is usually what causes flash flooding, so smarter urban planning and clear sewage systems are non-negotiable. On a larger national scale, building well-regulated dams and reservoirs really helps control river flow. And finally, public awareness and regular evacuation drills are just absolutely essential if we want to protect human lives when the waters actually do rise.
Section 6. Shrinking your carbon footprint.
So we've zoomed way out to look at the massive scale of the atmosphere, global climate change, and national flooding. It can honestly feel a bit overwhelming, right? But personal responsibility is where you can step up and actually make a difference. Your carbon footprint is basically defined as the total amount of carbon dioxide and other greenhouse gases that are released into the atmosphere strictly as a result of your personal daily activities. Every single time you leave the lights on when you leave a room, ride in a gas-powered car, or even toss out perfectly good items that end up sitting in a landfill, you are actively adding to those global emissions. Understanding your own carbon footprint is the very first step in realizing how your lifestyle directly connects to the global climate.
Fortunately, there's a really simple, highly actionable framework to shrink that footprint down, and you probably know it as the 3 R's: reduce, reuse, recycle. First up, reduce. Just avoid wasting water and food, and simply switch off appliances when you aren't using them to cut down your energy demand. Second, reuse. Instead of buying single-use plastics or stuff you throw away after one use, grab durable goods like cloth grocery bags and metal water bottles. Finally, recycle. Make sure paper, plastic, and glass are actually processed and turned into new materials instead of just piling up at a dump somewhere. These are practical, everyday steps you can literally start doing in your house today. Before we wrap this up, I want to leave you with this really powerful quote straight out of the textbook. The Amazon rainforest is often called the lungs of the earth because it produces a large amount of oxygen through photosynthesis. Deforestation in the Amazon reduces oxygen production and increases carbon dioxide. I absolutely love this quote because it brilliantly paints a picture of how deeply interconnected our planet truly is.
A single tree chopped down in South America shifts the delicate, invisible gas balance in the atmosphere that we all share, no matter where we happen to live. So, I want to leave you with one final provocative thought. If everyone, and I mean everyone, reduced their personal carbon footprint by just a tiny amount, if every single student watching this right now just actually implemented the 3 Rs, how could this bring about a massive positive change in our environment? Our atmosphere is an incredibly delicate, perfectly balanced machine. We might be the ones causing the disruption right now, but through awareness and collective action, we absolutely have the power to fix it. Think about that, and I'll catch you on the next explainer.